average speed, what is linear motion, rectilinear motion, all these things we have discussed so far, right?
Yes, sir.
Yes. So we were talking about uniform motion, and do tell me what is the graph of linear, what is the graph of a uniform motion? If you recall, we discussed this one. We were talking about distance time graph, right? Okay. So time and distance graph, using this two values, we were able to find the speed of the body, right? So for uniform motion was the how we were drawing the graph, we were obtaining a straight line for uniform motion. Okay, so in today's class we will study about non-uniform motion. All right, Prakash?
Yes, sir.
Okay, so say you first tell me what you understand by uniform motion, non-uniform motion. What happens in case of non-uniform motion?
Sir, when an object moves on a straight line in different speeds.
Yeah, will you please repeat?
When an object moves in a straight line in different speeds.
When an object moves
As-
at different speed at different interval of time. Exactly. So say a person is is journeying for 5 hours. He is traveling for 5 hours. Okay. So let's say for the first 1 hour, the speed of the person was, let's say, 5 kilometer per hour. For the next 2 hours, his speed was 6 kilometer per hour, right? And for the rest 2 hours, his speed was, let's say, 10 kilometer per hour. Then you see the time gap is not same here. There is no equal interval of time, neither there is equal speed in the interval of time. So that is case of a non-uniform motion. Okay, so we say that when an object travels at unequal speed at unequal interval of time, then the body is doing what? The body is doing a non-uniform motion, right?
Yes, sir.
Okay, so let's draw a graph for one. Let's say I'm giving you a value here, time and distance. Okay, remember we are talking about non-uniform motion here. Okay, so let's say for first 5 minutes, the distance traveled is, let's say, 10 kilometer. For next 15 minutes, the distance traveled was 25 kilometer. And for next 50 minutes, the distance traveled by was, let's say, 105 kilometer. So if you were to plot a graph, if you were to draw a distance time graph here, what would be the slope? Let's say on the horizontal axis, we represent x, or we represent time. Right, Mufas? This is your x axis. And the vertical axis that we call as y axis. And this is the origin. In short, we represent it as O. Okay, so let's say we were to draw, if we were to plot time on x-axis, let's say this is 10 minutes. Just let me erase this one. This one is 10 minutes. Then this is, let's say, 50 minutes. All right. And then again, this is 90 minutes. And this one is how much? This one is 130 minutes. So see, for the first 5 minutes, and also trace distance also on the y-axis. Okay, so let's take a scale of 10 kilometers here. So 10 kilometer, again, then it will be 20 kilometer, then 30 kilometer, then 40. All right. So see, for the first 5 minutes, how much distance has been traveled? Yes, my first. For 5 minutes, how much distance has been traveled by the body?
Sir, 10 kilometers.
It's 10 kilometer. So 5 minutes is lying somewhere here between 0 and 10 minutes. And this is your required point here. Now see,
Yes,
for 15 minutes, how many distance has been traveled and where will this 15 lie?
sir, 25 kilometers.
It has been 25 kilometer has been traveled. So just after just near to 10 minutes, it will be 15 minutes. This point here, see where I'm pointing here. So this will be your next graph then, right? And for 50 minutes, for 50 minutes, how many distance has been traveled?
Sir, 105 kilometers.
105 kilometer. Okay, so if we were to draw the graph further here, if you try to extend it more, it was 40, 50, 60. Somewhere here, it will be 100 kilometer. Right, Mufas?
Yes, sir.
Okay. So for 50 minutes, that is here, the graph goes like this all the way up to here. Okay. Now join the points starting from 0. Let's join the points. Now see here. This is not accurate very. Yes, see here. The line goes like this. Is the line straight here?
No, sir.
No, it's not a straight. It's a curved line here, right? So we say that for non-uniform motion, we will be obtaining a curved line. So this curved line represents what? It represents non-uniform motion, right? This curve line will represent non-uniform motion of the body. Hope you got this one. Okay.
Yes.
Okay. So let's draw one more. Okay. And you are required to send your answer to the number right now. Okay. I'm giving you the data. Okay, Mafaz?
Yes, sir.
So let's say the question is, a body is traveling at different speed at different interval of time as follows. The data is being given here. So say this is a time, this is a distance. Okay, for first 5 minutes, the distance traveled was, let's say, 25 kilometer. Okay, let it be only 15 kilometer. Okay, then for the next 15 minutes, the distance travel was only 20 kilometer. Okay, then for another 20, let's say, let it be 35. Then for next 35 minutes, the distance traveled by body was, it was 60 kilometer. Okay, now using these three data, plot a graph between time and distance and see if the line you are obtaining is curved or not. Okay, Mafas. So once you will draw the graph, send it on the number. Which number? The number from where you receive your class links. All right.
Yes, sir.
Okay, then take your time and draw this one. It's so summer vacation right now, right, Mufas?
Yes, sir.
Okay, okay. So when your summer vacation is ending?
Sir,
After Eid? After Eid, your schools will open, right?
wait, sir.
Okay.
Sir, August 20th, sir.
20th of August.
Yes, sir.
Okay, okay. So that's a long summer vacation. Okay, after you will draw this graph, I will tell you how to take the time scale, time and distance scale. Okay, like on the x-axis and y-axis, how do we take the time scale? All right, I'm
Yes, sir.
talking about this, the time interval, like I take 5 minutes, 10 minutes, and 15 minutes. So for different datas, how we decide that what time interval should be taken here. For example, in this case, the time is 5 minutes, 15 minutes, and 35 minutes. So what is a suitable time we should be taking? So we need to now look for the minimum value given in the question. So see here, it's 5 minutes. Okay, so we can start from 5 minutes as well. But we need to make sure that the interval on the time interval and the distance interval taken on the graph should be equal. There should be equal difference between this. Like what do I mean here? Like in between 5 and 10 and in between 10 and 15, there is equal gap of 5 minutes. Right, Mufas?
Yes,
Similarly,
sir.
after 15, I could take 20. I could have taken 20. Then after 20, I could have taken 25, then 30, then 35, and so on. Similarly, on the y-axis, on the distance axis, you also need to make sure that you take equal intervals. So for example, here it's 15 kilometers. It's starting from 15 kilometer. So we could start from here. We could instead start from what? We could start from 15 as well, then 30, then 45, then 60, right? So that all the values given in the question is covered. Like 15, it's covered here. 20 will lie between 15 and 30 here, right, Mufas?
Yes, sir.
And 60, we can see that it is lying here. Okay, now did you did the same thing? Did you follow this one?
Yes, sir.
Okay, okay, very good. Okay, once you complete it, send it on the number. Yes, Mafaz. Are you done?
Yes, sir.
Okay, okay. Shall we move ahead then?
Wait, sir. Send it.
Okay, okay. Send it and let me check that.
Yes, sir. I sent it.
Okay. I will receive that in a minute. All right. So I will check that once I receive that. All right. Now, so one thing in so far we have now, just to summarize what we have discussed so far, we talked about distance time graph, and we know that motion can be of two types, uniform and non-uniform motion, and we traced graph for both of them. So first we talked about uniform motion, and then Mafaz we talked about non-uniform motion. All right. So one thing in uniform motion, we noticed that the graph gives you a straight line, and that straight line represents the speed of the body. Okay, so it means it is constant. It is not changing with respect to time. One more thing in respect to uniform motion, you got to notice here that let's say if the graph is like this, if there is two cars running on a road at different speeds but at constant speed, car A is running at a constant speed of 50 km per hour, car B is running at a constant speed of 80 km per hour. How do we represent that on a same graph? So let's say the graph will be represented like this. The car having slower speed, that is 50 km per hour. This is the line representing the car having 50 km per hour, let's say, and the car having a speed of 80 km per hour. This is the graph of that car. This is the slope of that car here. So what do we notice here? The car having a higher speed is having a higher slope here, right, Mufas? This is the slope of car having higher speed, and this 50 km per hour, this line represents the slope of the car having lower speed. So we need to note one thing here in regard to uniform motion. The car having higher speed will have a higher slope. All right, Mafas? And the car having lower speed will have a lesser slope. So this is car B here, and this is car A here. Did you got this one?
Yes, sir.
Yeah, that is pretty simple. Okay, then now let's move to a case. What happens if the object is stationary, if the object is not moving, the time keeps on changing, but if the car is at a stationary position, so the distance means the position of the car is not changing, yet the time keeps on increasing. So in that case, how the graph will look like? Let's see that. See here, case. Okay, so the case is distance time graph when the body is stationary, meaning the body is not moving. Okay. So in this case, what will happen? The time will keep on increasing, but the distance change if the body is not moving? There will be no increment in the distance. No distance will be covered. Right, Mafas? Like if you park somewhere, the odometer, the reading of the odometer, does it changes?
No, sir.
Exactly. So here we will see that from 0 to 5 minutes, then 10 minutes, then 15 minutes, the time keeps on increasing, but the distance covered by the body remains 0. Okay, so in that case, what will happen? The graph, when we will plot the distance time graph for an object which is at a stationary position, we will observe that the graph will look something like this. You plot time in here. Okay, 0, 5, 10, and 15. So at 5 minutes, this is time. At 5 minutes, what was the position of the object here? It was not changing. Let's say the object is standing at this position on the y-axis. Or let's say the distance is standing at this position on the y-axis. At time t here, did the distance of the object change here? It still was 0 here. So it will be here, right, Mufas?
Yes, sir.
Okay. And when time clock to when it was 15 minutes past, when 15 minutes passed, then also there was no distance going by the object. So this is where it will lie on y-axis. So there's a line parallel to time here, line parallel to x-axis here. Okay, so we say that the distance time graph of an object which stops moving or which is at a stationary position gives you a straight line parallel to the time axis. Okay, so what did I say it here? See. Okay, remember this thing, it's very important. The distance time graph for a stationary body is a straight line parallel to the x-axis. Read this one, Mafaz, and do tell me if you have any confusion in understanding this one.
No, sir.
Okay, so this represents 0 speed as well. Okay, since the object is at a stationary, okay, right. And this here is representing distance, and this is your time here. So that is how you are required to draw the graph. All right.
Yes, sir.
Okay. Now, how to draw distance time graph? It is also part of the discussion, which is very, in fact, very important here. Look, Basically, to draw distance time graph, you will be using a graph paper. Okay, you know how a graph paper looks like. There are boxes in it, lots of boxes in it. All right, this is how a graph paper looks like. And on a graph paper, we usually plot distance time graph. Okay, so in this graph, you will see the smallest square, that will represent a distance of 1 centimeter. This side of the square will represent 1 centimeter on the graph. You could take millimeters also, but usually you will take it as 1 centimeter. Right, Mufaz? So suppose on the time axis, on the x-axis, you are required to write 10 minutes. You are required to write 10 minutes. Okay, so see here. You will, if you were to take, let's say, make some more divisions in it. Okay. Yeah, let's make more division in it. When you will see a graph paper, that will give you a better and clear idea. So what we will do here, see here. See this thing very closely here. Suppose we are required to, let's say, take a smaller value. Let's say we are required to write 5 minutes on x-axis. Okay, so we will draw a vertical line and we will take a horizontal line. Notice this black line which I have drawn here. Let me pass. So you are required to write 5 minutes on x-axis. So you will take this one here, 1, 2, 3, 4, 5. So after 5 squares, you will mark up one point here. So this distance is now going to represent 5 minutes. All right, Mufaz?
Yes,
Are you
sir.
getting this? Okay. So basically, the scale here is that 5 centimeter equals to 5 minutes here. All right. Or basically, you will say that 5 square means what? 5 minutes here. That is how we can take a scale on a on a graph paper. Okay. And also how we need to draw the two different lines, horizontal line and vertical axis. We should always draw a horizontal line OX on the graph paper to represent x-axis. So suppose you are required to represent x-axis. So you will take which line? Horizontal or vertical line?
So the vertical.
No, you will take horizontal line, no? Horizontal line is the line which is parallel to the ground. Okay. So this
Yes.
line will be used to represent x-axis. Remember this thing. Okay, it is this line. And vertical line, you will use it to represent which one?
Y-axis.
Y-axis. For y-axis, we will be using vertical axis. Okay. And this horizontal and vertical lines, where they meet, what do we call that? We call that as
Origin.
origin. This is where this vertical and horizontal axis will meet here. That is simply called origin. Okay. And you see, if you whenever you will write the distance and time here, let's say you write time. So you also need to mention this time is whether in second or minute. So after time in small in a bracket, you will write it like this, MIN, not the whole word, just in short. Similarly for distance also, Mufas, you will write distance and you will write if it's in meter or kilometer in short. All right.
Yes, sir.
Okay, so these are the basic things you need to take care of. Okay, and the most important part of drawing or plotting a graph is the time scale. Or basically the scale which you take. Okay, and this scale will basically depend on what? This scale will basically depend upon the values of time and distance provided in the question. Depends upon values of time and distance. Okay, so let's say you are now provided with a graph paper here. This is my graph paper. Okay, and you need to plot a distance time graph in this graph paper. This is not looking like a graph paper, although, because there are so many boxes in a square boxes in a graph paper, it is practically impossible to draw them right here. Just for explanation, understand it like this: if you are required to plot two values, let's say, of time and distance here, listen carefully, my fast. So the time is, it is let's say 100 hours, and the distance is, let's say, it is 1200 kilometer. Okay, and another reading is, let's say, it is 150 hours, and it is 2500 kilometer. So in this case, you are not required to take larger scale, you be using a smaller scale. Getting it? Why is it so? Because let's say if you represent it taking two smaller values, let's say if you represent it like this, you make how many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have taken 14 divisions here, and you have again taken some divisions here as well. All right. So you tell me, what skill should we take for 100 hours? Let me tell you how many divisions are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 divisions here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 divisions here. So on the graph paper, that is the size of the graph, that there could be maximum 14 divisions on the, what do you say, on the x-axis and on the y-axis. 16, 14 and 16, that is the maximum division. So the scale you will took for 100 hours and 150 hours, it should not exceed 16 division. Getting it? It should not exceed 14 division. Getting it, Mufaz?
Yes, sir.
Since they represent time on the x-axis, so 100 for 100 hours and 15 hours, the division should not exceed 14. And for the distance, it should not exceed 16. So that is how we are required to plot the graph. All right. Okay. Now the question is, what are the advantages of these time and distance graph? If you're studying something, there must be some advantage of it. All right. So the first advantages of time and of distance time graph is that the variation of distance traveled by an object with time can be seen more easily from a distance time graph than from the distant time values given in the table form. So if the distance and time and distance values are given in tabular form, as compared to this, if you trace them on a piece of graph paper, and that gives you a graph. All right, so that now gives you a more convenient understanding, that gives you a more variation of how much distance is travel at different time. Getting it?
Yes, sir.
All right, so for suppose nowadays you can create it on Excel as well. So if you point your cursor at any given point on this line, you will get the speed of the object at that specific point. Suppose you take your cursor at any given point on this line. So at that specific line, what was the speed of the object, that can be easily calculated. But that is on the computer. But we draw it manually at for the values given, for the values of time and distance given. We draw it manually on a piece of graph paper, right?
Yes, sir.
Okay. Now, drawing distance time graph on a piece of graph paper gives you information regarding the distance moved by the object at only a certain definite time interval. All right. Okay.
Yes.
So we get to know about three things here. We get to know about how many distances being traveled. We also get to know about the time at which that distance has been traveled. And the last thing is basically this line that gives you the speed of the object. That is it. Okay. Now see, there are some other types of graph as well. See this figure 9.8 here, Mafaz. See, that is called a bar diagram here. Okay. So what is this bar diagram now? A bar diagram is a diagram which shows informations in the form of bars. What are bars? These are thin rectangles. Okay, now let's try to study this figure here. This is a bar graph showing runs scored by a team in each over. For the first over, look, overs are given in the x-axis here, and on the y-axis, runs are being given here. For the first over, how many runs were scored? We can see it was 1 here because this bar is corresponding to 1. Right, Mufaz? Then for the second over, how much distance was travel? How many runs were scored?
5.
5. It corresponds to 5 on the y-axis. Similarly, for 6 overs, how many runs were scored? It
6.
was 6 here, since it corresponds to 6 on the y-axis. Okay, so it is such a graph in which the positions and heights of the bar represents the values of the variable quantity. Like here we took runs and overs. We could have taken speed also. We could have taken marks scored by you in your exams as well. We could have taken weights of man with his age as well. Like when he was 10 years old, let's say, let's draw a bar diagram like this. The person when he was of 1 year's age, when he was of 2 years age, when he was of 3 years age, let's draw his weight and age diagram. So this represents age and this represents weight here. Okay, so let's say for when the person was of 1 years old, his weight was, let's take it to be 5 kilogram. When the person was of 2 years old, then the weight was, let's say, 6 kg. Similarly, when the person was of 3 years old, it was 7 kg. Okay, look, the distance needs to be changed, right? So we see that are the position and heights same or different here? Position and height of bar here,
Yes,
they are
sir.
different. They are different, none of us. The
Yes.
position and height of the bars are different here, and the position and heights gives the respective value, their respective value corresponding to the y-axis. So when was the person 1 years old, his weight was 5 kg. It is corresponding to 5 here. Similarly, 6 kg was the person's weight when he was of 2 years old, and 7 kg when the person was of 3 years age. Okay, so that is a simply bar graph, right? Now, similarly, we have got another type of graph as well. All right, see this one here. Okay, what does it represent here? It represents the composition of oxygen in the composition of different gases in the atmosphere. See here, this oxygen, it must be representing 21%, right? Nitrogen is at 78% in nature, and there are other gases that is 1%. So this is such a graph in which the composition of different values are represented in the forms of slices, isn't it?
Yes, sir.
Okay, so have you ever eaten a pie?
No, sir.
No. So pie is basically it's a eatable thing. Okay, I think it's a cake. It's a cake basically. It looks like this. It looks like this here. Okay, so that's why it is called a pie chart. Okay, because you can take different slices out of it. So this is a pie chart. So what is a pie chart? It is a kind of graph or diagram which shows the percentage composition of something in the form of slices of a circle. Okay, so this whole circle will be representing 100%. Okay, and if you make different slices out of it, let's say you take this slice, you take out two slices from it. So one slice is, let's say it represents 15%. The another slice represents 10%. Okay, and this could be a value of anything, like it could be, let's say 15% boys in your school play volleyball. Okay, 10% of boys in your school play cricket. Okay, and the rest plays badminton. Okay, so if the question is asked, do tell me how many students play badminton. So from looking from this pie chart, we can get the value. Do tell me how many students play. That is 75% exactly. So we can represent different values with the help of a pie chart as well. Right. Similarly, we have got a line chart as well here. We have got a line chart also. See here, the age and weight is represented here of a given person here. So from 2 to 22 years, his weight is being represented here. See, for 2, when the person was of 2 years, his weight was 10. Then 4 years, again it was 10. It was 10 when the person reached 6 years age. It slightly increased. Okay, and then kept on increasing, and here it is constant here, somewhat constant. So this is a line graph, right?
Yes,
Okay.
sir.
Now this thing is pretty simple here. This figure is basically representing x-axis and y-axis on a piece of graph paper. All right. Okay. Now let me once again, if you did you got the steps, how do we draw the distance time graph on a piece of graph paper, or shall we discuss that one?
Mm,
We can just quickly sum it up. Okay, how to draw distance time graph on a piece of paper. Look, you can make the graph by following the given steps. First, draw two perpendicular lines to represent the two axes and mark them as x and as ox and oy. What are the perpendicular lines?
Sir, OX and OY.
Yeah, but what do we mean by perpendicular word here?
Sir, straight.
Yes, when one line falls upon another line at an angle of 90 degree, then the lines are said to be perpendicular to each other, right? So say we
Yes.
have taken this graph paper, okay, and we have drawn two lines that are perpendicular to each other, and the line at which they intersect each other, we will call it 0. Okay, mark the arrows. The horizontal line we will call it as x-axis, and the vertical line is called as y-axis. Okay, now you need to decide the quantity to be shown along the x-axis and that to be shown along the y-axis. See here, an example has been given here so that we can trace a diagram here. So the time is given 0, 1, 2, 3, 4, 5, 6. So pretty simple. 0 is this one. Let me change the color. Yeah, this is 0 already, the origin point. So no need to mark 0. Okay, my fast. So we'll start from 1, then 2, then 3, then 4, 5, 6, and so on. Now come to the distance time graph that is on the y-axis. Okay, you will start from where? From 0 or from 1?
So from 1.
From 1. Since 0, it's just simply the origin here. So 1, 2, 3, 4, 5, and 6, and so on. Okay, now you need to plot the graph. You need to draw the line here. So how do we do that? We will draw lines from both the axes here, from x-axis and from the y-axis for the given values. So keep drawing the values for 1 here like this, and from 1 of the y-axis as well. So they will meet here. All right. So for other values also, you will draw them like this. Keep on drawing, keep drawing them. Now, when you would have drawn all the values, when you would have drawn corresponding lines for all the values, now starting from this origin, you will try to meet all the points like this. So that line will give you basically the slope of the graph, and that will represent speed. Okay, it might represent other values as well for different types of graph. So in this case, it was a time and distance graph. And we know distance upon time gives me what of us?
So speed.
Speed. So hence this slope will represent speed here. Okay. So that is in short how we draw the what? Graph. See here. Again. And also the distance travel at distance interval is being represented by this point here. So for first 1 minute, 1 kilometer was traveled. For second minute, 2 kilometer was traveled. So this point of intersection represents time